removing that toxicity, especially from our food supply chain. We were building a new Apple facility in America, and one of the great products that we're going to be having produced at that is a range of baby food. Now, with the Defugo technology, I can remove the sugar, I can make it high fiber, I can bring the flavonoids and the polyphenols into it to make it an exceptional baby food. But what I couldn't get away from is the toxicity that's in our water supply. And we use water as part of our process. So I went to Emma and I said, Em, I need to make sure that the water that's going into this baby food has no chemicals in it, no pesticides in it. And I set her that task, and they went away, and not only did they achieve that task, they also developed processes to get rid of forever chemicals like PFASs and PFOSs that are building up in our environment every single day. So it was quite an amazing outcome that came from that little simple task that I thought I'd set. And what we're going to hear today from Emma is the evolution of that technology now into the wastewater space, which is very exciting.
Okay, that's very interesting too, and you may be interested to know that later on in the show, we have another show later, where we're actually going to be looking at wastewater as well, how to recover things like nitrogen and phosphorus and other nutrients back into productivity. So there's a kind of link with the rest of the show that will be coming up later. That's really good. Okay, so it's an exciting concept. Emma, you've been charged with revealing all. So we're going to hear a keynote from Emma about this development with wastewater and what she's actually been achieving with Defugo. So over to you, Emma.
Thank you very much. It's a real pleasure to be at COP27. Several years ago, I decided to go back to my engineering roots and see if I could help aid the expedition of decarbonization. So it's great to be here and see all the innovation that is around the conference. Now, today, instead of focusing on the detoxification bit in terms of industrial chemicals, I'm actually going to speak about our process that we've developed where we use wastewater and produce green hydrogen. So there's been a lot of talk about hydrogen lately, particularly green hydrogen. Is it economic? Does it use too much energy? Is it a viable decarbonisation solution? So I'll try and touch on those topics throughout this discussion. ecoX H2 is actually a collaboration between current technology in Canada and ecoX in Australia. So it's an international team trying to work towards solving global problems. What we've created is a process that solves two key environmental issues, and as such, we obtain greater value. So I'll talk about those two challenges, and I'll also present our solution. Next slide, please. Okay, so what is problem number one? Well, problem number one is inadequately treated ammonia in wastewater. Now, around the world, we produce 359 billion cubic meters of wastewater each year, and we only treat half of that, just half. So you may be wondering why in particular I'm talking about ammonia, and that's because it's toxic to aquatic life. So not only is it toxic to aquatic life, it also encourages algae blooms. So many people would be familiar with the red tides off the coast of Mexico and Florida. And in my home country of Australia, we look with trepidation towards the bleaching of the Great Barrier Reef, also contributed to via ammonia runoff. Now, the last point I wanted to make about ammonia is conventional wastewater treatment processes tend to produce nitrous oxide from ammonia. And nitrous oxides are about 298 times worse than CO2 as a greenhouse gas. So that's problem number one. Let's move to problem number two. Next slide, please. Now, at first, this might seem like an unrelated problem, but please bear with me and I'll get there in the end. So, problem number 2 is that heavy transport is a hard industry to decarbonise. And that's because long distances travelled means EV solutions are often difficult to implement. So if you have long periods of downtime for recharging, then obviously your operating costs increase and there's more inefficiencies with the transportation assets. Now, but it's very important that we still focus on decarbonising this sector, because in Western economies, about 18 to 20% of the annual greenhouse gas emissions are due to the transport industry. Next slide, please. So they are the 2 problems. What is the one solution? Well, our collaboration likes to call the solution the green highway. And what we've done is we've created, or we're wanting to drive to create, hydrogen production facilities along highways, and we want to strategically place those at areas of concentrated population. And the reason for that is if you've got an area of concentrated population, you normally have a wastewater treatment plant. And if you have a wastewater treatment plant, our process can remove the ammonia, then convert that ammonia to hydrogen in the place where you need it. Next slide, please. So what are the key benefits of our solution? Well, 2 key ones are cost of production, which I'll talk more to in several slides' time. And the other one is cost of transport. So if you think about a conventional hydrogen situation, you would normally have a large-scale, centrally located electrolyser to produce the hydrogen. If you're looking to decarbonise the transportation industry, you would then need to truck that hydrogen to many, many long locations, quite often remote locations, and you would have the associated transportation costs and the environmental impacts. So the positive of our process is you're actually producing the hydrogen at the place where you need it. And we're using really, really high-tech wastewater treatment to remove that ammonia, and as a byproduct, we're getting this valuable hydrogen for decarbonisation. Next slide, please. I'd like to now talk about some of the other goals that we're looking to achieve with this process. So firstly, we're wanting to convert wastewater treatment plants into energy storage systems. And that's a really exciting concept. We're taking an asset and we're also making it a revenue-generating asset. Now, the next point is that global hydrogen production, we can actually bring it now. We're utilising existing infrastructure, so our source material, that wastewater, is brought to the central point of treatment already. All that infrastructure is there, so we can take advantage of that. Now, the next point is that we avoid greenhouse gas generation, and as a result, we also have the benefit of greenhouse gas or carbon credits. So we're able to decarbonise an industry that's very hard to abate. Okay, next slide, please. Right, so how are we actually going to deliver this? Well, our technology works well when there are new wastewater treatment treatment systems. Our technology is a very, very effective tertiary treatment process. But more importantly, we can
Mine is buffering too.
actually use the ecoX H2 solution to retrofit to existing plants. And we're speaking with governments in the Americas and Australia on this concept. The third point there is that our comparisons have shown that the cost to build our process is comparable or cheaper than other denitrification systems. Okay. Next slide, please. So on this chart, I wanted to give an idea of the financial side. So here we have a theoretical wastewater treatment plant in the USA. Now, we've chosen a population of 170,000 people. And what you can see is that for an average flow rate and ammonia concentration for a typical wastewater treatment plant, a municipal one for 170,000 people, we are able to achieve 1,200 kilograms of hydrogen per day. Now, to put that into context, a 12-metre bus needs 8 kilograms of hydrogen to drive 100 kilometres. So if you compare that 8 kilograms with the 1,200 produced, you can see that's quite a significant amount of hydrogen to decarbonise a local community and the transportation industry. Now, the last line there shows the revenue generated, and we estimate that for this example, it would be around $3.5 million per annum in terms of hydrogen sales. But that's not the only positive from an economics perspective with the system. We actually produce multiple revenue streams. So we have the hydrogen sales, we create carbon credits, we provide a water treatment service, and we also produce a proprietary green chemical, which is very useful and environmentally friendly in both the medical, with uses in both the medical and food industries. So multiple revenue streams supporting that cost of production of hydrogen. Next slide, please. So while we're talking about cost of production of hydrogen, I have a slide here, a chart that has 3 columns. So if we focus on the one on the left first, the green one, this represents the range of the cost of production of hydrogen at present. Now, the green column on the right shows the future required cost of hydrogen if green hydrogen was to be competitive. Now, all these stats are from Bloomberg NEF. What you can see is the 2 green columns don't align. So there's work to be done between getting from the cost of green hydrogen at present to the cost of competitive green hydrogen that we need in the future. However, if we now focus on the blue column in the middle, this is the cost of production for the green hydrogen that is produced from our ecoX H2 process. You can see that because we have multiple revenue streams generating value, then we can produce hydrogen at a far lower cost, and we can produce green hydrogen at a competitive cost now. Next slide, please. So that's the business model. Now I'm going to explain a bit about how it works. Next slide, thanks. Right, so the ecoX H2 process is a 3-stage process. Phase 1 is at the loading phase, and that's where the wastewater containing ammonia travels through the treatment column. Now, in that treatment column, there's proprietary media that has been developed by Current Water Technologies. That media removes the ammonia, and the resulting effluent is clean water ready for discharge with ammonia levels less than 1 milligram per litre. Now, the next phase is the regeneration phase. So we clean the column using a brine, we wash the media, and the ammonia follows the brine through to the next phase. That treatment column is then clean and ready to go back to loading surface. The final phase is where we produce the hydrogen. So at this point, the ammonia follows the brine into the reactor, the electrolyzer, and we produce nitrogen and hydrogen as a result. So that's a very simplified version of what is a lot of research that's taken place over years, but I hope that gives you some idea of how the system works. Next slide, please. Now, this is a detailed version of what's happening inside the reactor. So what happens in the electrolyzer is the ammonia is split into benign nitrogen and valuable hydrogen. And a positive here is we don't produce the nitrous oxides that I was talking about earlier, so no greenhouse gases. The second point is that we're not producing nitrates and nitrites, which are also toxic to the environment and carcinogenic. So conventional wastewater treatment systems would produce this and then have to remove them, but we jumped that step. Okay. Next slide, please. Here you can see a picture of one of our remotely operated ammonia treatment plants in Virginia. Now, it's a smaller sized plant that you can see inside a 20-foot container. And what's great about the concept is the technology is scalable and modular. So we can find a solution that fits all sorts of throughputs and ammonia concentrations. Next slide, please. These are photos of one of our hydrogen production pilot plants. Just 2 months ago, this plant left the Current Water Technologies warehouse to the US military. Next slide, thanks. So we think there are many opportunities to convert waste to hydrogen. I've concentrated on the municipal wastewater treatment plant example, but we're also working with all sorts of industries, such as mining and oil and gas, in terms of cleaning up the ammonia in their water, agriculture, fertilizer, and food processing. So endless opportunities. And I think what's really exciting is to imagine that every municipal wastewater treatment plant could potentially be an energy storage system, and we could use that waste to produce hydrogen. And in fact, we do better than using the waste. We clean wastewater, a valuable environmental plus, and then we produce hydrogen as a byproduct. So we've solved two key valuable and sensitive environmental issues with one solution. Thank you.
Well, thank you very much indeed, Emma. Take a seat here. We'll have a little chat. We haven't got a long time, but maybe 10 minutes or so. So it used to be with wastewater treatment works that they try and harvest methane, wouldn't they?
Yes.
And use that for energy production. But then methane is a challenge all on its own because it's also a greenhouse gas. Yeah. And if it leaks out and whatever, it creates problems. So you've added another step, in a sense, to get from whatever's in there to basically hydrogen.
Yeah.
As a clean fuel that can be stored as well and then used whenever you want it, yeah?
Yeah. And I think for me, one of our key focuses was instead of just using energy to make hydrogen, we wanted to perform another job that was useful. And we didn't want to use clean water and we didn't want to use methane to make the hydrogen. So a valuable environmental and financial solution. Yeah.
I mean, people always talk about costs, and I was just trying to understand your cost curves a little bit. But is it one of those things that, is it cost even? Does it cost a bit more? Therefore, we need to scale it up, and then the costs will come down. Is this where we are?
We're finding that it's very cost efficient, and that's because we have all of those revenue streams. So we're finding the cost is definitely less than half of the revenue that we're calculating. Yeah.
Lastly, when moving away from wastewater treatment, you mentioned agriculture.
Yes.
Because, I mean, in the room here right now, we've got some friends who are from Africa, I think, and some parts of Africa do have wastewater treatment works, but some don't. Where could this be applied in agriculture?
In agriculture, well, two places. We're working with fertilizer production facilities, and that's important because the wastewater that comes from those production facilities is quite high in ammonia, so a very good source for hydrogen production. We also need to be careful about collecting runoff from agriculture. And I think before now, we haven't really had such an incentive to collect it. But now if we can have a financial reason to collect it and produce hydrogen that is a valuable product, then there may be more incentive to do that.
David, do you want to comment on this? Yeah.
Yeah, actually, from a Dayfugo point of view, one of the things I've been very, very interested in is Emma's work with aquaculture and the ability to not only make a healthier animal because of the ability to clean water, but also one of the big issues we have with intensified aquaculture and fish farming is the ammonia that is created around those farms, and that is something that Emma is actively
so
working
you're talking fish farming as well here as well.
That's
correct.
Correct.
Another area. So it's kind of everywhere where ammonia is coming from, basically. Wherever there's sources of ammonia, agriculture, wastewater treatment works, fish farms, anywhere else where ammonia is hanging around that we could harvest?
We're finding that in produced water in oil and gas industries and mining, so that's another big source of ammonia that we're looking to work with those industries to treat. So that would be a big one.
So this all began as a partnership or a relationship or between Dayfugo and ecoX Global, yes. And are you still working together? I mean, this one in Virginia, is that together or is that separate?
Look, from a Dayfugo point of view, as I mentioned when we started, detoxification is just so important for us. And if we don't get the water right, we have no chance of the next crop being clean. So from a Dayfugo point of view, we're introducing our partners, especially in the upstream and downstream side of the Dayfugo plants, to work with Emma to clean the water that's coming into my plant and clean the water that's going out of my plant. Because that's the recycle regeneration that Dayfugo needs to make the next generation of food that much cleaner.
And I'd just like to mention too, our partners in Canada, Current Water Technologies, they have been a big part in forming the technology behind this. So we've worked together as an international team, which has been really positive and really great. Yeah.
Tell me, I mean, all this work's going on, in a sense, because the world faces multiple crises at the moment. The creativity that's coming from the work you're doing, the work that so many people, it's fueled by the fact that we have a climate crisis, we have a loss of wildlife crisis, we need to get more, we have a resource waste crisis, all these things coming together. And do you think that, I mean, we were discussing earlier about how many people are a little bit concerned that some governments here are thinking about maybe ditching the 1.5 degree target. Does that stifle creativity if the world takes its foot off the accelerator towards a climate-friendly future?
I think that innovation is needed throughout this whole decarbonisation issue. And to drive innovation, you really need those government policies that encourage and discourage bad and good behaviour. And we're seeing it with in the green hydrogen space, for example, with the Inflation Reduction Act in the US, already a lot of technology is being drawn to that country. So I actually feel if countries aren't active in trying to reward innovation, then innovation will go elsewhere, and perhaps it won't be good in the long run for them.
David?
Yeah, look, I totally agree with Emma there. I think one of the big things that governments think innovation is a tax. It's not going to make money, so they're worried about their economy short-term and long-term. I encourage governments to look at technology like what Emma's doing because it's profitable. That is the key to this. We are taking two major problems. Wastewater, which you saw the figures, they're huge. You're fixing that and you're decarbonising one of the hardest industries to decarbonise, which is heavy transport. Governments need to look at this type of technology and see it not just for its brilliance, but also for the fact that it will provide the long-term green economy they're looking for. I've always been a little sceptical on hydrogen, I have to admit, but this is without a doubt the best business case I've seen for the hydrogen economy that's out there, because we're taking those two big problems and we're fixing it. You eat an elephant one mouthful at a time, and this is definitely a really good mouthful in the hydrogen economy.
Yeah. I mean, the hydrogen economy is many things, but you're saying green hydrogen, which is absolutely key. We know there's a difference between green hydrogen and other kinds of hydrogen. And what we want is green hydrogen, either made through this process or through renewable energy or other processes that might evolve through the creativity of people, because they know that governments are supposed to meet high targets. And, you know, this drives. I mean, renewable energy would not be where it is right now if there hadn't been 15 years ago the sense that targets were coming for governments to decarbonize their economies, and that led leaders like Germany to install a lot of renewable energy. You know, pump prime it with finance at the beginning, then it spilled over into China, and now it's gone all the way around the world. So you have to have that incentive. You have to have leaders in industry and business, but also leading governments willing to say we're going to incentivize this in some way, and then things move a lot faster because we don't have time.
Absolutely, Nick. And now from a Dayfugo point of view, if I can have my trucks delivering in a carbon neutral way and the trucks taking my products to market in a carbon neutral way, well, we've just completely decarbonised the supply chain, and that's exciting.
So we're going to have to leave it there. We've run out of time. They're whispering in my ear 1 minute, and that was about 10 seconds ago. Maybe we can just wrap this up and say thank you very much, David, for approaching us to have Dayfugo and Friends. We welcome that. That was good. These are areas that we don't normally dig deep into in terms of our shows. And I think it's important to give people an exposure to, it's not just, you know, wind turbines, it's not just this, it's not just that. It's all sectors of the economy that need to align with climate action and with the circular economy, which is the next big move up where nothing is waste and everything is used. Okay, thank you very much indeed.
Thank you.
Bye.
Do you want to act